Okay, so folks, I just wanted to show you how to solve a problem from either Charles' law or Gay-Lussac's law when you're looking for a temperature. So I'm jumping down all the way here to question number 1 in Gay-Lussac's section. It says a closed empty tank containing air at 97 kilopascals and 22 degrees Celsius survives a fire. If the tank is able to withstand a maximum internal pressure of 350 kilopascals, what is the maximum temperature it could have reached during the fire? So I'm just going to head down here. You can see I've got my equation all written out. And again, I suggest that we are looking for our variables. I prefer to plug them in and then rearrange. Some of you might prefer to rearrange first and then plug in. Either way, you're going to need to identify your variables. So it tells us initially the pressure is 97 kPa and the temperature is 22 degrees Celsius. Quick reminder, anytime you're using temperature in any of these problems, it needs to be converted to Kelvin, and you do so by adding 273 to the temperature in degrees Celsius. So in this case, it would equal 295 Kelvin. The final pressure, the pressure that we're going to assume would be our final pressure is 350 kPa. Here's the idea. The pressure inside this air cylinder cannot exceed this. So we'll assume that this is the maximum it could have reached in the fire and allow us to come up with the maximum temperature of the fire. So we're looking for T2. So I'm going to plug in. I get 97 kPa over top of 295 Kelvin, and I'm going to set that equal to the pressure of 350 kPa over T2. Now I'm doing this problem because you need to solve for temperature, and one of the things that people will often do in these problems is they'll forget that the temperature is in the denominator position. They'll take their 350 and divide the other side by 350, and they'll assume that leaves them with the final temperature. But really what it does is it leaves you with 1 over the final temperature, or the inverse in the temperature. So probably a little bit of a convoluted approach, but which would be best understood by people is to cross multiply here, and we'll bring T2 up to a numerator position. So we'd be left with 97 kPa times T2, and that's going to equal 350 kPa. I'll use brackets instead of the dot, times 295 Kelvin. So I'm going to solve for T2 now by dividing both sides by the 97 kPa. That'll get rid of the kPa and the 97 and leave me with T2, but I have to do the same thing on this side. So I'm going to divide by 97 kPa, and then if I grab my calculator and punch this all in, so we're 350 times 295 Kelvin, divide by 97 kPa, I end up with 1064 Kelvin. So that's the temperature in Kelvin. If you wanted that in degrees Celsius, remember you would just take away the 273, so minus 273, that would be 791 degrees Celsius. Okay, so I think there's another question on that page where you're looking for temperature. I think it's number 5 in Charles' law. Have a go at that, and if anybody has any questions, we can talk about those later.